Okay, so we talked about atmospheric winds. When we say winds, they are in the atmosphere, not in the ocean. They could be on the ocean, on land, on mountains, but winds generally mean in the atmosphere. We said there is excess energy, deficit energy, energy has to be moved. There is energy deficit here, energy surplus here, which means we have to constantly move energy from here to here. Why? Because we see that the poles are not getting colder and colder and colder. So even though they are losing energy, they must be getting some energy from space, losing back to space, but they're not getting colder and colder and colder, which means somebody must be bringing energy to compensate for this loss of energy, which is what the winds are doing. So we talked about all that, and we talked about the trade winds, northeasterlies, southeasterlies, which converge into this area that is shown here with these red target-like circles. They are called doldrums, which means very weak winds. If you're a sailor, how does a sailing ship work? It has these huge masts with cloth looking like thing which collects the wind energy, and you can turn them around and make the boat move. And these doldrums are places where there are very weak winds. If winds are coming from two directions, they will go to zero in the middle, and we said they go up together, and there is warm water, rising air, clouds, rain, etc. On the other hand, we said there are westerlies in the mid-latitudes. These are called mid-latitudes, low latitudes, mid-latitudes, and polar latitudes or high latitudes. So we have easterlies here and westerlies here, northeasterlies and southeasterlies here. You can see that in both hemispheres there are westerlies and easterlies at mid latitudes and polar latitudes. Now we are focusing on ocean currents. When the winds blow on the ocean, on land, if the wind blows, land cannot move, soil can fly away, leaves can fly away, and trash can fly away. But in the ocean, if you blow on the ocean, the water begins to move, and the winds create what are called currents in the ocean. So you can see some relation between the winds and the currents. So this is a complicated looking figure, but don't worry about it. We have trade winds here, which means winds are coming from the southeast and the northeast and pushing the waters westward. So there are currents going westward here. You can see the arrows, and you can see the arrows here as well. And this is a smaller ocean, the Atlantic Ocean, and this is even smaller here, the Indian Ocean. What we learned, very special thing that happens over the Indian Ocean that we learned about, is that winds are going from the southwest towards the northeast during the summer months. We call them southwesterlies. Remember the land heating, ocean heating, heat capacity, and all that good thing we learned about. And in the winter, land cools, it's got higher pressure, so winds are going from the northeast to the southeast, called northeasterlies. These currents shown, they are average over a whole year. So obviously when you make an average over the Indian Ocean, if the winds are completely changing direction, then it's not properly representing the seasonal changes. If you don't understand it, don't worry about it. Just remember that winds tend to have similar pattern to winds. So here you have westerly winds, so currents are also going from west to east because the winds are pushing the ocean this way. When you get close to the coasts, complicated things happen, and we haven't learned enough to go into those details, but approximately you can imagine that winds are pushing it this way and warm waters are coming this way because low latitudes have warm currents, and then the coast comes, so the currents are going north, and then they're going east with the westerly winds, then they're coming south again. So cold water is coming down here, being brought south by the current here, and warm waters are going west and then going north. So you can see there is a warm current going north here, warm current going across, cold current coming down, and so on. So similarly you have winds going in the other direction, so currents going to the west, coming south, coming east, and creating these circulations which are called gyres. Gyre, basically circulation of the water. If you don't understand, don't worry. There are many details. There are other ways that currents work here. There are currents going round and round because the Southern Ocean is like a channel. It has no boundaries. The Pacific Ocean has a boundary. It has North America on this side and Asia on this side, South America here and Australia on this side. There are some gaps here, so water can go through the gaps from the Pacific Ocean into this ocean, which is the Indian Ocean. So you have currents forming a gyre here as well, and the currents are going all the way north into the Arctic Ocean, and so on and so forth. Okay, many details exist which depend on how the rotation is affecting the currents and how the effect of rotation changes with latitude. Okay, those are complicated things. We will learn about Coriolis effect in a minute in the next podcast, but in the meantime let's just think about ocean currents in this way, that winds are dragging the ocean around and creating currents. But what else happens? Winds are also creating evaporation and precipitation. Water is going out of the ocean and falling into the ocean. Right? We said before that evaporation breaks the bonds between water molecules called the hydrogen bond. If you don't know what that is, you can read it up, or I have podcasts on that as well. When you break that bond and take that energy with the water molecule outside, you are taking energy from the ocean into the atmosphere. So ocean is getting colder because you are removing energy from it. Atmosphere will get warmer because you are putting energy into it. Water vapor, when it condenses, is going to release that latent heat of condensation. If you don't know what that means, look up on the web or on my podcast, or don't worry about it for now. What else happens? I asked in the last podcast, why is it that we cannot drink ocean water directly? Because it has too much salt in it. So when evaporation happens, only the water molecule goes out. The salt that is dissolved in the water remains in the ocean. Okay, so if you take a cup of water and you add salt and dissolve it, you think the density of this water will be higher than another glass of water which has no salt, or will it be lower? Will the water with salt be heavier than fresh water with no salt, or will it be lighter? I think you can intuitively imagine. If you cannot, then ask again somebody or me. When we add salt to water, it gets heavier. Why is it important? Because when you do evaporation from the ocean and the water molecule leaves and the salt remains behind, then that water is getting heavier because it's as if you added salt. You reduced water, which means you increased the salt concentration. That water gets heavier and it can sink. Okay, so winds are dragging it around, and then there is evaporation or cooling happening which can make the water heavier and make it sink. Or you can warm the surface with a lot of sunlight. And is warm water heavier than cold water or lighter? If they have the same amount of salt in the ocean, when you warm the surface with sunlight, will it get heavier or lighter? Okay, so you can do these experiments at home carefully with adult supervision. You take fresh water in a beaker, gently pour salty water into it without disturbing too much, and then you see if the salt water sinks to the bottom or floats on top. if it sinks to the bottom, means it's heavier, right? So you can do the same thing. Then you can warm the water. Well, this becomes a little bit tricky, so let's not do that. But you can imagine that if you warm the water, it's going to get lighter. So lighter water will not sink, heavier water will sink. So ocean is also being moved by water sinking in some places and water rising or floating in some places. Okay, other things happen. Think about the Bay of Bengal or the Amazon, where the river waters are coming in. Do river waters have as much salt as the ocean water? Of course not. Many times we drink river water. Sometimes you have to boil it and filter it, but it is not having as much salt as the ocean water, which means when the river flows into the ocean, it can float on top. So coastal waters generally have less salt, depends on many things, but in general, if fresh river water is coming, it can stay, mix and become less salty than the ocean water. So you have fresh water, salty water and less salty water, which is often called brackish water. B-R-A-C-K-I-S-H, brackish water. Okay, so a lot of the river fronts, river mouths have brackish water. Okay, so those are important things to remember. So this is the wind currents generated by these are the ocean currents generated by the winds. Westward currents, eastward currents, northward currents, southward currents, circulations, and so on and so forth. And these are called wind driven currents. We will see that in the ocean you also have another kind of current. As we mentioned, water sinks in some places, so becomes so heavy that it can sink all the way to the bottom. Remember, the bottom is several kilometers deep in most places, but the water is so heavy that it can sink like a rock, or it is not so heavy and will sink halfway to the bottom, and so on. So there is water going up and coming down as well because of temperature change, salinity or salt change, and hence density change. Okay, we'll come back and see that in the next podcast. We will see some nice animations provided by NASA, National Space what is NASA? National Aeronautics and Space Administration. As I said before, I should know this because I worked for NASA. I'm getting old, kids. And NOAA is National Oceanic and Atmospheric Administration. Both are in the US. There are many agencies from Europe and India who also make podcasts, but when I'm making these podcasts, I just go and collect whatever video I can find that is freely available that I can use and show them to you. Okay, so we'll come back and discuss the other circulation in the ocean that is created by density changes. Okay, see you in the next podcast.